And hello, welcome to our live stream. I'm glad we made it. I'm glad our cadence is still up, and I'm thanking you all for all the great questions that came in over the last 2 weeks. As a housekeeping in the beginning, please, I now start putting the descriptions and into the descriptions all of the open questions. We will update those as we go. We will carry the questions with us, which we don't answer. We will sometimes pick ones that aren't in there, but rest assured, the reason why we keep them in there is so that we don't forget, and so that you can, of course, know what might come up in the next live stream. Maybe in the future I will say what we're talking about in advance as well. This time though, we basically just decided what our most favorite question is, and I think it was the one from Reddit because I liked it a lot as well. So thank you. Oh shit, I forgot to look up the username. But in the post on Reddit, which is announcing this, there is still the history where the person asked us for the question. Thank you for the great question. It's an interest of me as well, and so I'm just like, well, Daniel, I think we should do a video. And he even said,
I love the questions. They're really, really good.
Yeah.
I'm so looking forward to this.
And he even said, well, we might be doing a blog post as well, but as an old news, but I'm not sure if I said this on YouTube as well. Part of the reason we're doing the live stream is because we know we're like blog posts, we're fairly slow with them.
They take time.
They take time, yeah. And then it's not that we don't want to take the time, but we rather invested in making great updates for the Portmaster. And thank you all as well for all the great feedback via mail, via responses on Reddit, comments on YouTube for our blog post, the new update, the 0.9 update with the graphs. It has been an encouragement to the team. And this is so much, it's so great. Thank you for the encouraging words. So this was my housekeeping and my introduction. Do you want to share something as well?
We're really excited to finally get the 0.9 update out. It was quite a journey to get there. We had to do a couple of changes to the core of the Portmaster and how it stores connections and how it can query them. So there was a lot of work in there, and the team has done a phenomenal job in tackling that and then tackling all the bugs after this big change. And I really love the result. And it's absolutely amazing, and I can't wait to go on and build on what we've done here to get the history going, so you can use all these powerful features, the querying, the filtering, the grouping, all that on historic data. And I'm looking forward to having 1 year worth of connection data of my own device and just looking through it and what I can find and doing reports on that and stuff like that. So really, really great technology, and we're looking forward to build upon.
Yeah. And it has been a great team effort. I think with big releases like these, it's it touched almost everyone.
It did, definitely.
So it did touch almost everyone. Of course, whatever. I don't want to get too much into details there, but for those who don't know, maybe we'll bring some guests in the future as well. You can tell us in the comments if you'd like to see other people from the team. I'm not forcing anyone onto a live stream or something, but if you would like to see people from the team, you can of course tell us as well. I think this is something. Yeah, if they see this, they will be surprised as well. But I just like you to get to know us a little bit better as well, as who we are. We're not that big. We're currently 9 people, and almost all of us here in Austria, but not all of us from Austria. So it's a very interesting bunch as well. But we love all. A fun bunch. That's true. Well then, let's get into the question. So we have been asked a lot, but I never thought about putting it into the live stream about what firewalls like if you could disable the Windows Firewall when you have the Portmaster installed. And I think this is a very great question to answer on a live stream at least once, and maybe go into a little bit more detail there as well. But a great additional question that came up, and this is the one I announced, like the one that comes from the subreddit, was what is the process a connection takes when I have something installed like Sptify, and how does it, like this connection, if I want to stream a song, how does it connect through the app, through the Portmaster, the Windows Firewall, the kernel, the maybe a switch on the network, the router, the ISP, the internet, then probably like a Sptify server, and then where does it land, and how are the rules? Who can decide what and what point? What part is DNS having in all of this? And I think this is all that I am like. This is the level to what I understand. Okay. And I'd like to maybe have Daniel explain it a little bit deeper into where Portmaster fits into all of this. What sort of like does the Portmaster do on its own? What does the SPN do in addition to it? And I think it's a very interesting topic. And if you have any further questions for the future, please leave a comment or just chat with us live. So both are options. We try to maybe incorporate those questions into a potential blog post for the future, of course, as well. So
okay, so let's start with the first one. That's a fairly easy, quick question. So the Windows Firewall lives on the same layer as the Portmaster, so they're kind of like pretty much the same kind of integration. Of course, they work very differently, but they're kind of on the same level. And they, of course, both control all kinds of traffic. What the Portmaster currently does not do is it does not control forwarded traffic. That's something it will do in the future, but right now it does not. Normally, you don't need that. If you use virtual machines, for example, then they might use forwarded traffic on your device, depending on the technology. That's something you'd have to research. Other than that, they pretty much work the same way. Should you disable the Windows Firewall? If you want, you can. The Portmaster does the full protection that the Windows Firewall does too. We by default don't disable the Windows Firewall, because you might have something configured there. There might be some things you blocked already, or and we don't want to lift these blocks. So the Portmaster can work very well together with the Windows Firewall. That's not a problem. Normally, Windows Firewall doesn't block a lot of stuff, but that means you'll also still be getting these pop-ups sometimes for applications that want to set connections. It's like, okay, do you want to have this application accept incoming connections? Like, in which kind of profile are you? Is that the work or the private profile? So that will still happen. If you don't like that, you can, of course, disable the Windows Firewall.
Isn't it private and public?
Oh,
are you talking about
maybe
this?
Is. Yeah, sorry. Yeah. Maybe it's this.
This pop-up where you can select which one you are, and
it's a bit different depending on the Windows language.
Yeah.
Yeah. So that's the one. So, but you can safely disable Windows Firewall if you don't like it.
Great. So I think the most interesting question in regards to this might be other software as well. Of course, Glasswire is something that we've been asked about a lot, but Simplewall and stuff like that. What is, like, people are asking, how does this interact? You're just said, like with the Windows Firewall, if you have something blocked, then the Portmaster respects that block and does not sort of allow a connection through. But like, does the Portmaster still see the connection? Can you like allow something in a Windows Firewall? How does the Portmaster handle stuff that is allowed explicitly in the Windows Firewall? How does that interfere, or like, how does that?
So, I'm not sure exactly how it works for blocked connections. So it could be that if one application blocks a connection, that the next one would not see it. That depends on the exact implementation um, of like chaining firewalls after each other. For loud connections, the Portmaster will definitely see everything that goes through. So the Portmaster has a Windows driver, the kernel extension, which lives in kernel space. So it becomes part of the operating system, and that communicates with the Portmaster background service, the system service that runs and does all the heavy lifting. Glasswire and Glasswire is a bit difficult to like make hard statements on because their software is closed source. We don't know exactly how they're doing it, but more or less they are just listening to traffic and then injecting additional rules into the kind of their own space in the Windows network stack, similar to the Windows Firewall, which can create rules in these in there. And Simplewall is the same thing. It listens for connections, kind of watches them, and then if you decide something, it injects a rule to block that. And the Portmaster has its own state table in there and decides when to block something, when to allow something. And packets are directly reported to the background service, which can then also load the full packet data to do further inspection if we need that. For example, to look at the encryption and things like that, or to like detect special packages in protocols that could invade your privacy. That's not yet released, but that's something we've been working on for a while, or have been working on in the past and had to pause.
And the capability is there. I think this was fairly clear. So the capability is there for us. And I think maybe to just reiterate, so you're saying that the Windows has an integrated network stack.
Yeah.
And as far as we know, because we don't know for sure in regards to Glasswire, but Glasswire hooks into this.
Yes, it does.
And we know for sure.
It definitely does hook into it. We just don't know how exactly.
Okay.
And what features in the kernel they use and which they don't use.
Okay.
That's the part we don't know. We know they do it.
But it's a kernel interface, this network stack provided by Windows itself.
Yeah. So
and Simplewall and Glasswire are both accessing this
Yes,
existing
Simplewall doesn't add code to the kernel itself. It just lives in user space. So there are two different API levels. There's kind of the user space API level for normal applications, and then there's the kernel space API level. We're at the kernel space API level. We can see absolutely everything. And Simplewall is just at the user space API level. And Glasswire, I'm not sure right now anymore.
Okay.
How they do it.
But they're closed source, so we can only observe them from the outside. We could not make any definitive statement anyway. But so some people have been asking, of course, in regards to Windows Firewall, if they can disable it. But another question sometimes pops in, like if I have Glasswire and Portmaster installed next to each other, I think our common recommendation is to not do something like this. As you said, like layering firewalls, there can be interference, and you sort of said like one hitting after the other. Can I know which one is in front of which? Can I change it maybe then as well?
I don't think you can change it. If you query the system of there's an API endpoint from Windows that you can query that will give you the full data it has about everything configured in the network stack. The Portmaster does that. If you like click on copy debug information, it actually does that and simplifies that information down to what is useful for us for debugging. And it will show if other firewalls are enabled.
Okay.
And so that would show it. You could find out in there, but I don't think there's a way to change that at the outset. You'd have to change applications. There's still like priority flags you can set.
Yeah.
It's not that easy. Yeah.
I see. Yeah, and of course you cannot. Yeah. Okay. No. Interesting. So what is like? And some people have been observing or thinking they have observed, and it's something that I haven't tested myself yet. I don't know for sure that sometimes if an application is set on allow in Glasswire, that it's sometimes goes past Portmaster. At least that's how I understood it. Is this
that's definitely from how at least we've configured, and we are telling Windows so. Like, unless it ignores what we say, that's impossible. There are like, if you respond to the Windows network stack, what to do with the packet, there's kind of a normal allow and block operation, and there's a force block, which means I veto every other allow, and we do that. So even if another firewall allows it, we definitely veto that decision and say, no, this is blocked. No chance it's going out. And Windows should respect that. If that really happens, it would be great if we can take a look. It will be time consuming for us, so I can't say we're going to do it immediately, but it's definitely something that we would want to know that happens.
Yeah. Love to investigate and to understand better. Yeah. We are still, as you said, like from a technology perspective, we know that the Portmaster has a greater capability and that we can improve some of the capabilities it has in general, and of course fix some of those issues if they are like reproducible as well. So of course, like the Portmaster running on so many different systems, Linux, Windows 10. So I just recently learned of somebody running it on a Windows server. Very interesting environments, many stuff. Yeah. Many stuff that can run next to the Portmaster, which might want to do connections as well. So it's, for us, a question without a debug log is always very difficult. So if you write us an email and I tell you, well, here is the guide on how to send us debug information. Yes, okay, yes, well, then please don't be mad. It's just like the settings can be so different with where you're at, and you can of course look through the debug info as well before sending it. I think we do this in the Portmaster anyway, so you can clean anything out you don't want to send us. That's all good. We don't want to see anything, and it's self-deleting as well. It's just it's deposited. It doesn't stay with us for that long as well. So I even had to ask some of you to send me another debug info because we didn't have the time to take a look in time, and then the information got auto deleted. What time is it? How long is it? 2 weeks?
A month.
A month? Okay. Well, see, we are pretty busy. No, but from the point that the first email came in, I just want to clarify that quickly. It came in, and I usually try to digest it first, ask obvious questions, maybe point you towards some doc files, gain some new information, and if it does not work, then of course I'm going to ask Daniel, well, what's going on? Do you have an idea as well? But we try to sort of keep continuing fixing bugs for all of you, and not periodically for one or two specific ones. So this is the reason why I try to catch and digest and improve the information before it gets handed off to Daniel. Okay, but what you're saying is, in general, you would say that if Glasswire and Portmaster are installed next to each other, even if Glasswire is in that stack in front of the Portmaster by accident or whatever, if it allows something and then Portmaster sees it, it would still block it. And if it would be the other way around, it would not continue.
Possibly. Depends on the exact behavior. It might just present the packet to other firewalls, depending on how it's integrated. Because, for example, Simplewall doesn't integrate into the stack itself. It just watches. So it just gets an event from the network stack that there was a packet. It might also get events for packets that are blocked, just because that's also an event that you can subtract for.
Mhm.
But Simplewall in that case does the looking at and the filtering are two different systems. For Portmaster, that's one system. We see the packet, we decide, and then we either forward it again or we drop it or block it. Yeah.
Mhm. So so we are not sure how the stack is handling if it hits the portmaster first, portmaster says no, if it would present the package maybe to Glasswire afterwards as well.
Yeah, we don't know exactly. That's something we could test, how exactly that all that blocking thing work, but it's not really high priority. If anyone of you likes to go down that route and just test it out,
sure,
please tell us what you found.
Oh,
it
yeah.
Be interesting.
we love to gather information in regards to this. We don't have the time for all of this. We don't have, as I said, we need to focus on a couple of things first. One of them, of course, is getting better information to all of you out there. And this sort of like very detailed information, we feel like if we have the time, we're going to do it, but not very soon. So
yeah.
Don't wait for it. If you want to do it, if you want to figure it out, please do so. We might be able to help you in that regard, so you can reach out before you start doing it as well. Get connected either via mail, via GitHub, I think is a good way to reach Danielle.
Yeah.
Or of course via Twitter as well. Now I put the Twitter handles in the bottom as well, so you can of course tweet at us. So all good options to reach us. Okay, well then. You want to add something to that network stack integration stuff, or do you want to continue to the other question, like the whole path a packet would take from?
Yeah, let's do that.
Okay.
How deep do you want to go with that? Should I just start digging and you just stop me when I go too deep? Is that a good idea?
Oh, see. Yeah, let's give this a shot.
Let's just okay.
We'll figure it out. If it's not detailed enough for you, please ask us. We might go deeper, of course, at one point if the situation arises. But yeah, just get cracking.
Okay, so I think the use case is Sptify requesting a song from the service.
I just like that use case. I came up with it.
Good. Okay, so we have the Sptify process that started. You click on something and you want it to play a song. So it gets that song from wherever that song is. So what it first does, it creates a network connection. That means it requests from the operating system a socket, which means a communication interface. And it says, I want to connect to this domain and this port. The operating system then is like, okay, this domain, I don't know what to do with domain, so we'll use DNS to resolve that. So the operating system takes the name, sends a DNS query, it sends that query, and then the portmaster sees the DNS query goes through the network stack. Portmaster sees that DNS query, sees that it's not going to the portmaster. It's like, wait a second, but I want to handle DNS, so it just starts rerouting that query. So it goes, it injects the packet again, modified, so it'll go to continue through the network stack, but go back to the portmaster. Then the query arrives at the portmaster, the DNS query, portmaster will start resolve that query. Here first checks are applied, so a couple rules are applied here before the query even goes out. That's only some very little rules because on Windows the DNS queries are handled by the DNS service by Windows, so we don't actually know at this point which process is querying that domain. So we're like, it could be anyone, and because we have app settings, we can't yet just like do anything. We do a couple things that are really important, so some self-protection things so that you can bypass the portmaster. That a couple of minor things are done here, but then that query is sent off to the DNS server configured in the Portmaster. There is a reply. The Portmaster checks if that query was blocked by the resolver already, and will present you as that in the UI. And then I think there are some other last checks on the packet if that was resolved correctly. For example, if the resolver returned IP addresses that it shouldn't be returning, like the IP address of your device, because that's an attack a website can use to rebind a DNS address to your local router and then kind of attack you by using weird DNS replies. So we check for that. If all of that is okay, we send the packet back to the Windows DNS service, which brings up the IP addresses for that domain name back to the Windows component that's creating the connection for Sptify.
Okay.
So that was the DNS part.
Exactly. I just want to quickly go through it again because it was very lengthy and you were really going deep there. But I think it's cool. I like this sort of stuff and I just wanted to go through it quickly again, just for like pacing reasons and you being able to take a sip. So like Sptify app, it only has a domain. It does not have an IP address. And so in this case, of course, if it has an IP address, this whole thing is skipped. But basically what it does, it sends this to the DNS resolver of Windows. Windows DNS resolver tries to resolve it. Portmaster detects that there is a DNS request going out, handles some stuff in the background already, pre-checks, then sends out a new DNS request on its own.
A secured one.
A secured one via
DNS.
TLS to the service that you're configured in the Portmaster. This is also the reason why you don't have to configure anything in the DNS on the operating system, just as
Everything
an info
is
here.
seamless.
Exactly, because the Portmaster sees the package and hijacks it. It does not need to be sent to the Portmaster itself because it detects it on its own. And then, so it sees this connection, it hijacks it, it takes it to itself, it reroutes it then after those checks, gets the answer and then sends the answer back to the DNS resolver of Windows, which then answers Sptify itself.
Yes.
So Sptify thinks it talks to the and it actually talks to the DNS resolver. Does the DNS resolver itself, like Windows DNS resolver, know that its connection has been hijacked?
No, it doesn't.
Okay, so Windows does not see or does not know that this DNS request it thinks it sent out to resolve Sptify.com
was actually resolved Portmaster.
Was handled by the Portmaster.
Well,
it can detect it if it's looking for it, but the DNS resolver itself.
But we add records to the response the Portmaster sends out to tell everyone that the Portmaster handled this request. So we're very transparent about this. And if you use any tool to like debugging tool, like common one in Linux is dig, to query a domain, you'll always see
that the Portmaster.
So DNS has different sections in their packets, and there's an extra section, and they're like we don't only tell you that the Portmaster was it, but we tell you why it decided. If it's blocked, we tell you why it was blocked.
Yeah.
So very nice for debugging settings too. So we are very transparent about it, but just Windows doesn't care if it was hijacked or not.
Yeah.
As long as it responds, it's happy. Yeah. So.
Okay.
So
So now the Portmaster send back the answer to the DNS request. For everybody who doesn't know, this now is an IP address.
Yeah.
So the DNS resolver sent Sptify the process back an IP address. Like the answer to Sptify.com now is an IP address. So
Sptify, or like Windows acting on behalf of Sptify, has an IP address that it can connect to.
Yeah.
So what happens now? What happens now is that the Windows will start creating a connection. So that's when packets actually start flowing in the direction of this IP address.
Windows does that for the Sptify process.
Yeah.
Yeah, just to clarify that. So the Sptify was doing the request initially, but now Windows opens up the connection.
For it, yeah. So,
okay.
Like normally the whole TCP/IP stack is always handled by the kernel, by the operating system, not by the application.
Yeah. But
because that's so commonly used everywhere. It doesn't make sense for every application to implement that themselves.
sure.
Yeah, they
Just
just
wanted to
say,
clarify
give me a TCP connection to that thing, and Windows does it, and like, here you go. And
Sweet.
that's it. So, okay.
And where does now, because you said earlier, we don't, where does the Portmaster see which connection was, like which process was creating this?
We'll get to this now.
Okay.
Great. Okay. So the first packet of the connection is run down through the networking stack. The Portmaster sees it. The Portmaster saves the packet and like tells Windows that it absorbed it. So like Portmaster just took it and more or less like dropped it, you could say, but it keeps a copy of it in the Windows kernel extension, and it sends it extracts kind of the header information, kind of metadata about that packet, and sends it up to the Portmaster. And it waits for the Portmaster to make a decision. So the Portmaster up there.
Yeah, I think you said Portmaster twice. So the
so
kernel, like our
the
kernel
extension in the kernel and the background service running.
Exactly.
So
both Portmaster for you, but for us it's different
components.
Components of the Portmaster stack. There is a great picture in the docs where you can have a look where it explains the different assets of it. But I think if we're saying Portmaster and Portmaster, so the kernel extension, our kernel extension
to the core service,
our core service, they are now talking to each other for the first time.
Well, no, they were initialized together.
Oh yeah. But
this packet for the first time.
Yes, this packet now was sent up for the first time.
Yeah. So
the copy of the header of this packet.
Like the metadata information.
Yeah. Okay.
It's a bit more prepared. There's some stuff that we can add there too. But so the Portmaster is the first idea of the connection it's handling. So the first thing it needs to do is it needs to find out like what this connection is. Like where is it coming from? Where is it going to? Like do we know a domain of this? So it starts looking for where it's coming from. So it takes the source IP address and port and checks the Windows state tables for the process that sent that. We're working on some updates, so in the future we might be getting that information directly from the kernel extension. Right now that's a separate lookup. That's not too bad. It just might fail sometimes, and that's just how things are on computers.
This is
network is volatile. Things just die. That's normal. So then we find out what the process is. Then we load the process information so we know what's the process name, what's the binary. We know exactly all about that things. So we know where it's coming from. Then we want to know where it's going to. So we have an IP address because in the packet doesn't have a domain name. In some cases it does, but normally, like for the generic use case, it does not. And then we check if the Portmaster resolved a domain to that IP address recently. So we check our the cache, the DS cache, and we're like, hey, we know that IP address. We just resolved this domain to this IP address. So great. That we see now that packet is coming from this process going to this IP and domain. And then with IP and domain, we can start enriching that information with intelligence data. So we go and check all the filter lists we have and check if you're the domain or the IP address, or from the IP address we have a GUIP database. So we derive the country, we get the internet organization. You could simplify that as a data center. So we know to which country, to which data center it's going. We know who owns the IP address, all that stuff. And then we take all that stuff and check it against the filter list. So we know, is there anything do we know anything about this country, this domain, IP address, all that sort of stuff, enrich that information.
Filter lists including rules. Like,
Not yet. And
Not yet.
we're just gathering information at this point. So now we've
but you
gathered
checked
all this.
against, you said.
It's checked against the list just to register that in the list.
Okay.
So we know everything about this now.
Mm-hmm.
And then, with all that information, we start the decision process.
Mm-hmm.
Decision process is a list of like criteria we kind of go through
Okay.
and check if.
May I just, so because it was already, like, to wrap this up until this point.
Okay.
So we had the DNS request.
Yeah.
The process has an IP address. It sends this to the resolver. Resolver Portmaster hijacks, does the DNS resolving, pre-checks there, and then hands back an IP address.
Yeah.
And we're now started with this IP address. You said that then the process gets this IP address and asks for a connection. And we are now like in the state when the
first packet has been sent
from my computer
from the process into the network stack of your device.
Into the network stack, and in there where the Portmaster core service, like the kernel extension lives, where we first picked up the same place where we first picked up the DNS request. We're now picking up this first package, and we're currently seeing this first package for the first time. You said it's extracting some of the information from this packet.
Yeah.
It sends it up to the Portmaster core service, which does not live in the kernel. It lives in a user space. In there, it gathers all the information it has. It checks what is the process for the first time that's connected to, because earlier we were only talking to Windows itself, and we're only seeing it in the kernel and stuff. So for the first time, we gather the information, which process actually sent that information. And we're gathering additional information in regards to what does this IP address tell us, which country is it going to, what data center. So it's now we're in this information stage. But from an application perspective, the Sptify process itself, what it has seen so far was I sent a request for an IP address.
I think that's also handled by the OS. So all what Sptify did until now is just say, Windows, give me a connection to this domain.
Okay.
That port. That's everything Sptify did.
Up until this point.
Only this one thing.
Just for context, how much time are we talking for all of this? Like,
so
just a quick answer, if you.
Okay.
Because I want to continue the process.
If the DNS response was cached locally, we're definitely below 1 millisecond.
Below 1 millisecond.
Yes.
Okay. And if it's not cached, then of course it depends on the DNS request.
So that the DNS request might add, if we already have a connection open to the DNS server, will add 10 to 20 milliseconds, maybe less.
Okay, so we're talking like below 1 second. So this is
far below.
Yeah. But just for people to know. Yeah. So we're very fast in that regard. This all is fast. The slow stuff comes later.
Everything feels like
instantaneous.
Yeah.
We know about some bugs in regards to stuff might be hung up in a part of this process, but this comes later. So if you and we might get into this as well, but I'm not sure. So for now,
we have the first packet. We got all the information we can about this first packet,
and we're now right in front of the decision process.
Yes.
Okay.
So the decision process is simply going through a list of conditions that are more or less complex, and check if one of these things gives us a decision. So first we start with what's the kind of default network action. That will be checked in the beginning because that influences thing in the process. But first we go through, does this connection, is it blocked by some of the force block settings? So we have some force block settings that cannot be overridden by rules in order to give you certainty that this will never happen. So if you enable the force block setting, this will never happen. And then we go through the user-defined rules because they can override all the rest of the decisions. Then we go through filter lists and some other things that do like decisions. And if all that does not spark a decision, at the end we look at what's the default network action. That's the first setting you have in the app settings. and we take that. That can either be an allow or a block, or a prompt, which means we'll ask you and then decide. So, and whatever is the output of that process is reported back to the kernel extension. But before this process is completed, we can also check like if there's a reason we want to investigate that packet further. Further, the core service can request the full packet data from the kernel extension. So we'll just send, hey, please give me the full packet. I want to do some more analysis.
I think this is now going deep.
Okay.
I think so. Now this would be the normal process.
Yeah.
So it would go through the whole, and I think
we'll skip that for now. It's not that feature's not live yet, but that's kind of the one that we said is there in a proof of concept stage. But we can do even more analysis. But for now, let's stop here.
Okay.
And the Portmaster reports back to the kernel what to do with that packet. So it'll either drop it, which means it kind of just it disappears, abducted, and then it's block, which means the kernel extension will actively communicate to the Windows kernel that that the packet was blocked and that there shouldn't be expected any response to it. That's something that we haven't had for a while, but we have now implemented and we'll be starting testing next week. So that will speed up a couple things if you've experienced like slow response times on Windows.
This was the reason. And maybe explain it because it was waiting for the packets. But I think this was a little bit too deep. But okay, so we're now sending. Maybe let's not go too deep into this.
And then the port, or it's an allowed, and the Portmaster takes the packet like saved and reinjects it into a network stack so it can continue its journey through to the destination. So now we're at the end of the network stack. Should we continue?
It's a good question. Thanks for asking. So from the beginning, let me quickly go through it again. I think we haven't even touched the whole question yet.
The packet hasn't even left the device.
The original packet, that's true.
Yeah.
Okay, but let me quickly go. So the process as sent to Windows the request, I want to connect to Spotify, it's like the Sptify process connected to the Windows or sent out to Windows. I want to connect to Spotify.com on that port. This was picked up by the Portmaster, and the Portmaster did this pre-check stuff with the DNS. It resolved the DNS and stuff. You can go back. You have the beauty to go back if you want to re-listen to this. And then the Portmaster gives the operating system back the information, what IP address this domain resolves to. Then then it starts to try to connect to the send out its first packet, and the Portmaster picks this up again. It does some information gathering, and then it goes with all that information from top to bottom through the rules. This actually is represented in the settings of the Portmaster as well, so that they are actually in this hierarchical order.
More or less.
More or less.
It is correct. Sometimes it doesn't matter which order they are.
But it goes from top to bottom.
The important parts
the rule of thumb
are
is
in the correct order.
The rule of thumb is if it's if you go from top to bottom, if you're not sure what your connection will be doing, and we're thinking of maybe introducing a pre-check there as well, just what would my rules affect. But if you're not sure right at this moment, if the setting above does something to block the connection will be blocked. And as you go further down, then of course, it's maybe some special case we can say here as well as I think if you have something like in your custom rules, a block all, and you have an allow one connection, is it, if you have an allow for this connection and it sees that, it will ignore the settings below it, doesn't it?
Yeah, definitely. Like the first rule that matches is picked and this process stops.
Okay.
We're done. We have a decision, we're done.
Okay, so in your custom rules, if you have a block star and above it an allow DE for Germany, then all connections to Germany, as soon as it gets there, I have a rule that fits, connections allowed.
Yeah.
And if it then drops down to the next setting and it says, well, block star, block everything, then every other connection would be blocked.
Yeah.
But it does matter in which order they are.
They definitely matter.
Because if the star is above, then at this
everything
point,
is blocked.
oh well.
Yeah.
Okay. And if I take force block above everything, then everything is blocked anyway. So force block and then put allow DE in the bottom would not work.
Yeah.
Okay, great. So,
So
but if I have just one more thing, if I have the default network action to blocked, so the one in the very top where there's like those quick settings, if I have that toggled to block, but then allow it in the rules itself, then it will be allowed as well.
Yeah.
Because the default network
default
action
is only chosen when there's no other thing we found to know whether it should be allowed or not.
Yeah. If you understand, give us a thumb up. But I think I hope we're doing a good job explaining this. We will, of course, improve upon this as well. If you have suggestions, please let us know as well. Okay.
So the packet is reaching the end of the network stack, and that's kind of where the Portmaster side of things ends, and that's where the SPN things start.
Let's skip the SPN for today. Maybe we will go look if you're interested in hearing how the packages connect through the SPN. We might touch upon this next week.
Really interesting to see like a difference between like how we would connect without the SPN and with the SPN, because there's a big difference.
Yeah. And I think we will only be here for 14 more minutes, so not gonna do it today.
Okay. Good.
So how does the packet continue if you don't opt it to upgrade the Portmaster? How does it do with the basic Portmaster?
So should we go through the normal one without the SPN?
Yeah.
Okay.
Just quickly.
Okay. So
maybe a high level now.
Okay, high level. So
we don't need to go into it.
The kernel now has a packet that it knows should go out. Then it has to look at the IP address to see where it's going to. Normally with your devices, you'll be in a kind of home or enterprise network. They just have a default gateway. That means just every packet you know where it goes to, send to that thing. That's probably your router or modem or whatever you call that. And it sends it there. And from there, it just forwards that to your ISP. And where your ISP is, things get a bit more interesting because we're now in the proper internet. So there's no just send everything their address. It has to figure out where the packet should go. And that's where something called BGP comes into play, which is the Border Gateway Protocol, where kind of multiple data centers are kind of gossip about like who's new to kind of the playground and where they're at and what stuff they're doing and what their IP addresses they have, and they kind of gossip around all this information.
Who are the cool kids? I see. Okay, well.
So they kind of like exchange information about like the state of the internet. And like side note, this is in the process of being secured, but a lot of networks aren't, so you can just spoof that. You can just go like, hey, I own that IP address. Well, sure, send me all traffic for that IP address. And a lot of networks will happily do that. And so things that happened were like that, like credit card transactions just went through Russia.
Yeah, but we're way too deep, please.
Yeah, just a side note. So, so this router then has this whole table of where networks are on the internet, and kind of is like, okay, what's the next nearest destination, and sends it to next router. And the next router is again, okay, this goes there. What's the next nearest way to there? And goes there, and then that router next one is again, okay, what's the nearest way to there, and then sends it along. And that happens like as often as need be until you finally reach the data center where that IP address lives that you want to access, and then it continues into the data center to that server to get that resource you want. Final side note, interesting tidbit, the return packet can actually go through a very different route.
Really?
Yeah, because the decision how a packet is routed is made at every router from scratch. So every router looks at a packet, is like, okay, that IP address, how do we get it like nearer to that IP address. I think this way, and the other router might be I think this way. And like some routers also do load balancing. They have like I have this route and this route, and they're like more or less the same. So I'll roll a dice and just put it their order. So your packets could be all over the place.
Okay, but in that regard, they're like the pack. Now we're talking about one packet, but afterwards those streams stay the same.
No.
No, they can change.
Yeah, sure.
Okay. Let's not go into detail. I think that I think an important part of the question was, and I might have not put it into the description correctly, and that's why I'm still here and he's not doing a monologue. I think some part you glanced over, or would of some of the questions which would follow up would be in regards to what does my ISP now see, like. After the Portmaster has handled it, we were already talking about DNS, which is encrypted via TLS. So what does basically now, we have left the computer now twice basically for the DNS request and for the first package that has been sent. But maybe now that we left the computer in our minds as well, from your, like if you have an Ethernet port, what goes out there and what part of outside the network stack, because this we already discussed as well in the beginning, like as soon as it leaves the computer, what else, like you're connected to a switch maybe, and then you connected to a modem and to a router before that. And then you're connected via cable or whatever to your ISP. What does the ISP see? And then you're at this border thing, as you said. But like, what sort of like parts? What can they interject? What can they see? How can they influence you still at this point? And what maybe an interesting question, but I can ask it later as well, would be: does it matter who owns the router? But let's start at the beginning. You're at the Ethernet cable that's leaving your computer. What part see, and like what influence can it sort of like have on this connection being established?
So the packet, like as soon as it leaves your device, the packet stays the same. So everyone along that route can see like everything that's there to see. So that's like primarily for DNS, of course, if it's not encrypted. That's like the domain name that you're trying to access.
But with us, it's encrypted. So what can they
yeah.
see if it's encrypted?
They're encrypted with like the Portmaster Secure DNS feature. They don't see that. They just see the following packet. So they see where is it coming from and where is it going to.
Okay.
So they can connect the dots to locate that IP address, which might or might not have multiple devices behind it, or even thousands. You never know. And the destination IP address, which is a server. So if you have the money, and that's not that expensive, you can just run a DNS query database where you just save all of the queries you see, and you can build up a pretty decent picture of which domains map to which IP address. So getting the domain name to an IP address is in a lot of cases really easy. So they probably know like where you're connecting to. With things like Cloudflare, things become different because there's so many domains on Cloudflare. So if you connect to Cloudflare, there's actually improved privacy there from that perspective, like except from Cloudflare. But so from your ISP, because your ISP doesn't know like what you're accessing behind Cloudflare.
Yeah. So you're connecting. What does your ISP see? Your ISP sees your IP address, and that you're connecting to a DNS server. That's all they see.
Yeah.
If you're using Portmaster Secure DNS, that's all that they see. Your IP address, of course, your ISP knows this and sees this, and the IP address. If you use the SPN, then they don't see that. But we're talking about, like without the SPN, we're talking about you just install the Portmaster, you decide to go into the description, click on the download button, download and install the Portmaster now, and without upgrading, just using it as it is. With only doing this, your ISP instantly does not see anymore what domains you're connecting to. And because Daniel was saying Cloudflare, the default is Cloudflare. It's a privacy iffy decision, I'd say, but it has been the fastest.
Like Apple.
Yeah,
they promise privacy. They seem to be doing it, but you never know for sure.
Yeah, and the reason why we're using it just quickly is because it's the fastest, and we out of the box, and we now ask you in the pre-screen as well. You can decide for a more privacy respecting option, but keep in mind all of them will be slower. So your DNS requests will be slower just because their servers are slower and they're not.
Yeah, and heavily depends on where you are at your
That is true as well. But
so there's some test there's some value in testing which one works well for you.
Yeah, and but so this is for DNS. So at this point, because your router of course sees that connection as well, can your router block the connection to this?
Definitely.
Okay.
Everyone along the line can block it.
Okay,
everyone can see and save that traffic for later.
If your ISP does not like you to use Cloudflare, they can block it. But they cannot distinguish what packet you're sending, so they cannot block it based on the content because that's encrypted. They can only just say, well, for our customers, we don't want them to use Cloudflare.
Yeah, it's hopefully encrypted. There's still websites out there that
don't use encryption. I'm talking about the DNS request.
Oh, sorry.
And this if you use the Portmaster, it was always encrypted.
Yeah.
There is no, hopefully, it's always encrypted by DNS. If you use
Portmaster, DNS is always encrypted.
Yeah. If you, of course, disable secure DNS, then you do you. But like if you use a secure DNS, then in the Portmaster, it's always encrypted. Your ISP can only say, well, we don't want you to connect to Cloudflare maybe or a different provider, Quad9. NextDNS or whatever. This is still something that they see, but they don't see anymore what you're asking them. So they don't see what domain you want to connect to. And then afterwards, if the connection is established, like with the Sptify, as you said, like it's leaving you now. The Portmaster did all the decision making. The connection is approved. It's leaving. Now, what do they see? Let's assume it's HTTPS and it's encrypted.
Okay.
So what does the ISP now see?
So for TLS 1, well, up to TLS 1 and including TLS 1.2, that's still the current standard. We're in the process of introducing TLS 1.3. That's coming slowly, but TLS 1.2 is still the default in most cases. They will see the domain name.
Who would have to do the upgrade to TLS 1.3? Can we do this as a safe thing?
No, like the browsers and all the providers, plus the websites too, because for the benefit in that case. So we can cover that in another episode. Like
okay.
TLS 1.3
just so you know, of course, if you're using the SPN, this changes as well. With the SPN, of course, we encrypt that part as well. So they don't know. Yeah. But without the SPN, it's very likely that the domain name is included with the IP address, your IP address and the IP address you're connecting to, and the domain name. What else is there to see?
Well, ports. There's things you could derive from the how packages are made or how they different implementations do things differently, so you could derive what kind of device it is, depending on the encryption option set or stuff like that.
And they see. So what do they see? They see what encryption option has been used.
Yeah.
So even though you're connecting from your home, and as you already hinted earlier, your router is the one that gives the final IP address for leaving. So even though your phone and your laptop and your computer are all on the same network, and they are all leaving with the same IP address, your house, the way how they're encrypted, the connection itself can give an indication of what the device was that originated. Yeah. The Portmaster cannot do something against it without the SPN.
Yeah.
Okay.
Yeah.
So without the SPN, they would still probably see your IP address, the domain name, and
destination IP address.
Destination IP address, origin IP address, yours, and the domain name, and maybe have a hint on what device we're actually using as well.
Yeah.
Okay, and so at this point, the ISP now sees this connection coming through. Can the ISP do something else? Can they block this connection at this point?
They can drop any connection they want.
And now they can block based on the domain name as well.
Yeah.
They can, but you said earlier about like, if they would have a DNS themselves, they could block based on the IP address also. They don't need the domain name.
Yes, there is some fault to this as explained because like Cloudflare IP addresses have like a gazillion domains, so the collateral damage would be very high, but they could.
Okay.
Yeah,
So basically, of course, if it's easier to just take from the packet the domain name and the IP address, they already know where you want to connect to. But basically, with the upgrade, the TLS upgrade, that would introduce a new step for them, but it might not be.
There's some protection against that in TLS 1.3, depending on some variables. So it's not always there, but there's improved protection. But we can talk about that in another episode.
Sure.
That's
if you want to see,
very in depth.
Yeah, I understand. So if you want to see an episode on TLS and different options of it, let us know. Maybe you are gonna prepare some slides as well. We're not sure. Maybe. We used to have some episodes with
the
slides.
things are all of our like viewers are asking, why the hell is the domain name in there? I'm using SecurityNet to protect myself. Why is my computer leaking domain name again? Well, the answer is pretty simple. With HTTPS, especially with the Cloudflare, they have a gazillion domains behind a couple of key addresses. And if you open a connection to a website, the browser will want to check if that website can present a valid certificate for the secure connection. And that server serving that gazillion domains has to know which certificate to give you, because if it just tries a random one, it'll fail. So you'll have to tell the server in plain text what domain you want to access so that it can give you the correct certificate and set up the encryption properly. So it's kind of like a chicken and egg problem we're having here.
You need to tell him what certificate you're asking for to actually encrypt the thing to be sure that nobody else could see it.
Yeah.
But you need to ask, of
to
course,
then
at least
the
once.
Domain name again to that. Yeah.
Okay.
So okay.
But we're partly like, and if your ISP is not allowed to see it, of course, this is an issue, and so therefore we have been working on the SPN for this exact reason, and the SPN is helping you in that regard. Very cool, but we can of course go into details about this as well. I think we're like, from a time perspective, nearly done. Yeah. What else do you want to share?
I think it has been a challenging episode, like a very in-depth.
Yeah. I hope you liked it. It has been very much more in depth than we up until now have done.
Yeah.
But I liked it. I hope you did too. If you like me to maybe interject more often and repeat, please tell us. If you like me to less interject and let Danielle keep going and going and going, tell us so as well. There are some things you can always do. Leave us a comment with new questions that you have. Of course, if you haven't tried the Portmaster, now there's a link in the description, so just give it a try. We're moving out of beta in the coming weeks. We are very confident at this point that you will not have any issues, not have any problems. So please give it a try. What else is there? Yeah, if you want to support what we are doing, upgrade to the SPN. It's how we fund ourselves. It's how we keep on developing. Pay Danielle to think about how to encrypt and secure your traffic and protect your privacy. I think that's it from my side. Do you want to add anything?
We're working on a lot of really cool stuff right now. A lot of really good improvements. Rafael hinted at them before. We don't have time to cover them right now. Hopefully we'll cover them next time, and you'll already be able to try it out. So looking forward to that. But I think
me too.
That's it.
Okay, well then, you can always reach us via hello@safing, email is in the description, you can tweet at us, handles are here as well, and in the description also, like, comment, subscribe. Are we YouTubers now? Not sure. Well, have a good one, and see you all around.
Don't.
I just, for everybody to know, I need to stop the recording.